Hello friends, welcome to Learner's Planet. Friends, this is our second session for sets. In the previous session, we discussed the basic terminologies related to set. What is a set? What is equal? What are different types of sets? Equal sets, equivalent sets, singleton sets, null sets, and what are subsets and proper subsets. In this session, we'll be taking some problems based on sets, and then we'll be discussing some more properties, more concepts related to sets. Okay, so just get ready with your paper and pen, and let's start. Now let's take the first question. Here the set A where x such that x belongs to R means real numbers, x square is equal to 16 and 2x is equal to 6. Now if x square is equal to 16, that means x is equal to plus minus 4. Plus 4 minus 4, because x is actually a real number, and 2x is equal to 6, that means x is equal to 3. So here it is mentioned a and, right? That means x square must be 16 and 2x must be 6, right? So that is actually not at all possible. That means x is a null set. There are no elements in the set A. X is not a null set, I'm sorry, A is a null set, because x is plus minus 4 and 3. So both the things are not possible. Okay, so A is a null set. There are no elements in set A. Now this question, the number of proper subsets of set, this particular set 1, 2, 3. Now in the last session I gave you the direct formula to find out the number of subsets. So number of subsets will be 2 raised to n. Here n is 3, there are 3 elements, so it is 2 cube, that's 8. So there are 8 subsets. Okay, but we are asked about proper subsets. So proper subset will be 2 raised to n minus 1, because there is one set, that is 1, 2, 3 itself, right? Now if this set is this is also a subset, but this subset and this is same, right? So the 1, 2, 3 is not proper subset of this. In case of proper subset, at least one element should be extra. Okay, but 1, 2, 3, there are 3 elements in this set, and 1, 2, 3, there are 3 elements in this set. So these two are subsets of each other, but none of them is a proper subset of any other, right? So there is one subset exists out of 8 subsets, that is this. So if we take this out, we eliminate this, we'll be left with 2 raised to 3 minus 1, that is 8 minus 1, that is 7. So there will be 7 proper subsets of this set. You can say 5, then 1, 2, 3, 1, 2, 2, 3, 1, 3, right? 1, 2, 3, 4, 5, 6, 7. So these 7 are proper, I'm sorry, this is null set. These 7 are proper subsets. Okay, so be very clear about it. If the number of subsets are asked, 2 raised to n will be there. If number of proper subsets are asked, then 2 raised to n minus 1 will be there. Okay. Now let's see some properties of subsets. Here A is subset of B and B is subset of C. Then we have to prove that A is subset of C. Now that's very simple. What you can do is you just assume an element x. Okay, now x belongs to A. X is an element and x belongs to A, right? Now since A is subset of B, that means x belongs to B also, because what is the definition of subsets? All the elements of set A are there in set B. If x is an element in set A, then x should be definitely an element in set B, right? So A is subset of B. If x belongs to A, then x belongs to B also, right? Now B is subset of C. So if x belongs to B, x belongs to C also. Okay, so if x belongs to C, that means A is subset of C also, right? We started with A is subset of B. We assume one element x that belongs to A. Since A is subset of B, that means x belongs to B also. Now B is subset of C, that means x belongs to C also, right? So we started with x belongs to A and we reach up to x belongs to C. That means if x belongs to C, that means A is subset of C. This is the sign of subset. and this is the sign of proper subset. Okay, we can take one example. So example over here, A is 1 2 3, B is 2 3 1, and C is 3 2 1. Right? So this is the perfect example for this property. A is subset of B because all the elements of A are there in set B. B is subset of C because all the elements of B are there in C. Hence A is subset of C because all the elements of A are there in C. Okay? Now let's see this one. A is equal to B if and only if A is subset of B and B is subset of A. Right? See, whenever you are having the proof that problems, you in sets, what you do is you assume one elements belongs to one set and then proceed. Right? Now A is subset of B and B is subset of A, that is given. Right? So we start from this side, and A is subset of B and B is subset of A. Now I assume one element, that is X. Okay. Now X belongs to A. Now if A is subset of B, X belongs to B also, right? So if X belongs to A, X belongs to B, that means A is subset of B. Okay. Now secondly, X belongs to B and X belongs to A, that means B is subset of A, right? So if X is element of A and X is element of B, that means A is subset of B, that means B is subset of A. That is possible only when A is equal to B, right? Here X is any element. Maybe there are 3 elements, 4 elements in set A, that really doesn't matter, but if we are talking about any element X, okay? So if X belongs to A and A is subset of B, that means definitely X belongs to B, right? And if X belongs to B and B is subset of A, that means definitely X belongs to A. Okay, so that's B is subset of A. That means A is equal to B. Conversely, what we can do is we assume A is equal to B. Now if A is equal to B, that means what? Any element X that belongs to A will definitely belongs to B also. X belongs to A and X belongs to B because A is equal to B. That means X belongs to A and X belongs to B, that means A is subset of B, isn't it? Because all the elements of A are there in set B also. Similarly, if X belongs to B and X belongs to A, that means A is equal to B. Okay, if A is equal to B, that means X belongs to B and X belongs to A, that means B is subset of A, right? So you can go this way and this way. So you can write the entire all the steps mentioned over here. Okay, but you should be conceptually clear. Next we have universal set. See, universal set, what exactly is the master set, you can say. If there are some sets under consideration, then there happens to be a set which is a superset of each one of the given sets, and this is called as universal set, right? Suppose I have a set A that's 1 3 5 7. That is a set of all odd natural numbers, and I am having the other set 2 4 6 8. That is a set B, that is a set of all even natural numbers. Then N is, that is the set of natural numbers, that is the universal set. Okay, over here. So A is proper subset of N, B is proper subset of N, A and B, these are individual sets, and N is the universal set for both of these sets. Okay, so in the context of human population studies, the universal set consists of all people in the world. Okay, set of Americans, set of Indians, set of maybe Britishers, and the set of the humans in the world is the master set, or we can say universal set. Okay, here A is 1 2 3 4, B is 2 5 6, C is 1 3 7 8 9. So what will be the universal set? 1 2 3 4 5 6 7 8 9. So that is the universal set. So in universal set, all the elements of all the sets will be there in this. Okay, so A, B, C, all of them are proper subset of U. Okay, and that is the master set. All the elements of A, B and C will be there in the universal set. Now let's have a quick recap of subsets of the sets of set of real numbers. We have already discussed this in our function session, so I'll be just giving you the brief idea of it. Natural numbers, we know 1, 2, 3, 4, all numbers which we use in counting, we call them as natural numbers. So this is the set of natural numbers, starts from 1. Set of whole numbers start with 0. So all the elements of n will be there in the set W, or we can say n is proper subset of W. N is subset of W, or you can say n is proper subset of W. All the elements of n will be there in the set W, in the set whole numbers. Similarly, next is integers. Okay, integers are negative whole numbers, 0 and positive whole numbers. So the next series is n is subset of W and W is subset of Z, right? Here in between n and W, W is having one element extra and Z is having many elements extra than W. Okay, so all the elements of W will be there in the set of integers. Next is rational numbers that we represent by Q, that is rational numbers can be represented in P by Q form where Q is not equal to 0, that is the denominator is not equal to 0. So all the integers will be part of rational numbers. So series goes on, n is subset of W, W is subset of Z and Z is subset of Q. And next is the master set, that is the universal set, that is real numbers. Right, so Q is subset of R, so N is subset of W, W is subset of Z, Z is subset of Q and Q is subset of R. Right, so Q is actually rational numbers. So apart from rational numbers we have irrational numbers also, so irrational numbers is also subset of R. Right, but rational numbers and irrational numbers, both of these sets are different sets, or we can say disjoint sets. What exactly disjoint sets are, we'll discuss later on, but there is no common element between two sets, then we call them disjoint sets. Okay, no common element. So since these are rational numbers and these are irrational numbers, so both of them are opposite of each other, so there is not any element which is there in both the sets. So Q and I are disjoint sets. So these up to here Q is subset of R, and that is rational numbers are subset of real numbers and irrational numbers are also subset of real numbers. Okay, and real number is the universal set of all these sets. Okay, and keep all these notations in your mind. Natural numbers, whole numbers, integers. If it is Z plus, then set of positive integers. Positive integers, that means 1, 2, 3, 4, 5, 6. Q plus, set of positive rational numbers. R plus, set of positive real numbers. R is set of real numbers, but R plus is set of positive real numbers. 0 is considered as neither positive nor negative. Right. So if you are asked about non-negative integers, non-negative integers, then you will be including 0 also, but in case of positive integers you will start it from 1. Right, non-negative, that is 0 will be included, but in case of positive 0 will not be included because 0 is neither positive nor negative. Next important thing is power set. The collection of all subsets of a set A is called the power set of A. It is denoted as PA. Right, now suppose A is 1, 2, 3. So how many subsets will be there? That is 2 raised to 3. That's 8 subsets will be there. 1, 2, 3, 4, 5, 6, 7, 8. Right, so set, null set 1, 2, 3, 4, 5, 6, 7, 8, and set of all these sets, all 5, 1, 2, 3, all these are like what? These are subsets of set A, and the set of all these sets will be power sets, power set. Okay, so how many sets will be there in this power set? 2 cube, that is 8, because there are 3 elements in set A. Okay, so collection of all subsets of set A is the power set. Okay, the empty set and the set A itself are subsets of A, so these are elements of power set A. The power set of a given set is always a non-empty set. Okay, it cannot be an empty set, it will always be a non-empty set. So you should not be confused between universal set and power set. Universal set is master set of all the sets, and power set is actually master set of all the subsets. Okay, in case of power sets, you'll be able to see the sets inside the curly brackets, right? This is the curly bracket, and all these are actually sets. These are sets, and these are actually subsets of A, right? So this is actually the collection of subsets, and U is the collection of elements only. So be very clear, power set is the collection of subsets, and universal set is collection of elements only. Okay, that is a major difference between the two. Next thing which we are going to discuss is Venn diagrams. The combination of rectangles and circles are called as Venn diagrams, Venn Euler or Venn diagrams. The universal set is represented by rectangle and other sets are represented by circle. Okay, if A is a subset of B, then circle representing A is drawn in circle representing B. A is subset of B. So that is, or you can say this is the set B and this is the set A, right? So A is subset of B. Two disjoint sets are represented by non-intersecting circles. So these two are disjoint sets. That means there are no common elements between A and B, right? If there are some common elements, then these sort of sets we will get. These sort of circles will get, right? So this portion is common. That means there are some elements common between A and B, right? Suppose A is 1, 2, 3 and B is 2, 4, 6. That means 2 is a common element between A and B. So A and B are not disjoint sets. There are some elements common between these two. So this way we present set A and B. But if there is nothing common between A and B, suppose A is this and B is say 5, 6, 7, right? So there are no common elements between A and B. That means A and B are disjoint sets, and these we represent them by two non-intersecting circles. So these two are disjoint sets, non-intersecting circles. They are not intersecting each other. Okay. Here you can see a universal set, and inside this universal set a set A is there, right? If A and B are not equal but they have some common elements, then to represent A and B we draw two intersecting circles as I have shown you over here, right? So this way you can the A and B two sets are not equal but they have some common elements. Maybe number of elements in A and B are different, right? Maybe A is having 3 elements, B is having 4 elements, but some of the elements are common between the two. That means some of the elements belong to A also and B also. Okay, so this way we draw the circles. Okay. Now we discuss operations on sets. See, the chapter is really easy. You just have to concentrate over here. Just try to understand the things. It's not at all that difficult. Union of sets. The union of two sets A and B is the set of all those elements which are either in A or in B. In symbolic form, union of two sets is represented as A union B, right? A union B. So A union B, that means X such that X belongs to A or X belongs to B. I take an example. A is a set 1, 2, 1, 2 and B is the set 2, 3, 4. Then the universal set will be 1, 2, 3, 4. All the elements of A will be there, all the elements of B will be there, but no repetition will be there. Since 2 is there in set A also and 2 is there in the set B also, but we will write 2 only once, okay, in the universal set. So precisely all the elements of A, all the elements of B, but there is no repetition. So that is actually universal set. And here we represent by circle like this. The universal set is represented by this rectangle. I have mentioned U over here. So this rectangle is a universal set. In this rectangle there are two circles, set A and set B. right? Now if these two circles are intersecting each other, that means there are some common elements between A and B. This is the perfect example. Here it is 1, 3 and 4, and here it is 2. So this 2 is actually part of A also, this 2 is the part of B also, right? So we represent the Venn diagram like this. Okay, be very clear about it. This is a universal set. 1, 2, 3 and 4, all the 4 elements are there. 1, 2, 3, 4, and 2 is common between A and B. So we place 2 between these two, the space that is getting intersected by this circle. Okay, that is a common space between these two circles, right? If suppose any set C is also there, that is maybe 5, 6, 7, right? So set C will be apart. Okay, because nothing is common between A, B and C, right? So in that case universal set will be 1, 2, 3, 4, 5, 6, 7, and set C will be outside, inside the rectangle, but not included in this, but the circle of C will be different. Okay, there is no intersection between C and A and C and B. Okay, so here we can see A is subset of A union B and B is also subset of A union B. Okay, universal set U, if I take this, so A is subset of A union B. A union B, that means universal set. That's actually A union B. So A is subset of A union B and B is also subset of A union B. So A is subset of U and B is also subset of U. Similarly, we can have union of 3 or more sets. Suppose I have set 1, that's 1, 2, 3, 4. Set B, that is maybe 4, 5, 6, 7. And I have set C, that is 4, maybe 9, 10 and 11, right? So we can see a common element 4 over there. So how do we represent? This way. This is set A, B and C. Okay, if we have suppose 4, 5, 10 and 11, and here I am having suppose 4, 5, 3 and 7. Okay, now you see what is the element that is common among the 3 circles? That is number 4. So I'll write number 4 over here. Okay, now what is the element that is common between A and B? A and B, 4 is already gone. Now we are left with 3. So between A and B, 3 is common. Okay, so 3 is also gone. Now the remaining element in A is 1 and 2. So I'll write 1 and 2 over here. Okay, in case of B and C, we have 4 is already gone. 5 is there in between B and C. So 5 will write over here. Okay, so 5 is gone. 3 we have already taken. Now we are left with 7 only. In case of C, 4 we have written, 5 we have written. Now 10 and 11 are exclusive elements which are not there in any sets. So 10 and 11. So this is the representation of data in like by way of Venn diagram, and this is the universal set U. Okay, so this is how we present the data in Venn diagram with the help of Venn diagram. Okay, so this U over here is A union B union C. Okay, A union B union C. That means all the elements of A, B and C are there. Some of the elements are common between A and B, some of the elements are common between B and C, some of the elements are common among A, B and C, all of them. Okay, so this is how we fill up the Venn diagram. We'll be taking problems based on Venn diagram, then it will be better cleared in your mind. Now intersection of sets, what is that? Just now we have studied union of sets. Now what is intersection of sets? If two sets A and B is the intersection of two sets A and B is the set of all those elements which belongs to both A and B. A intersection B is such that X belongs to A and X belongs to B also. Okay, so there are some elements which are the elements of set A and set B, both of them. Okay, so we call them A intersection B, right? So here we can see this universal set, and we have two sets A and B, and this is the common portion that is shaded blue, that is actually A intersection B. Okay, I take an example. A is 1, 2, 3, B is 1, 5, 6. Then there is one element 1 that is common between A and B. So if you fill up this Venn diagram, what you do, you will put 1 over here, 2 and 3 here, and 5 and 6 over here, right? So A intersection B is 1. Okay, A union B is 1, 2, 3, 5, 6. Okay, so you got the difference. A intersection B, that means the common elements, the set of common elements, and A union B is set of all elements. So be very clear about a union and intersection. Okay. Now since in this case one element, at least one element is there that is part of A also and that is part of B also. So A intersection B is actually that particular element. So as in the previous case we discussed, A intersection B is 1, right? Now 1 is element of A also and 1 is element of B also, right? So A intersection B will be subset of, obviously subset of A also, and A intersection B will be subset of B also. Okay, may or may not be proper subset, but definitely subset. Okay, because 1 is there in A also, 1 is there in B also, and because of that A intersection B is 1. So A intersection B, I'm sorry, A intersection B is subset of A, and A intersection B will be subset of B. Similarly, we can discuss the case of intersection of more sets, right? So that's diagrammatic representation is there, and I have already discussed the example in this case over here. So that is this portion, this number 4 is actually A intersection B intersection C. Okay, because that is the common element among all these sets. A intersection B is 3, right? A intersection B intersection C is 4. Then B intersection C is 5. That is the element common between B and C. And A intersection B, only A intersection B, it's a null set because there is no element that is actually common between A and B. There is just one element that is common between among A, B and C, that is number 4. Okay, so that's very simple. So how do we represent the intersection of 3 sets? That is A intersection B intersection C, union of 3 sets, A union B union C. If there are more sets, then you can increase the series. Okay, so that's pretty simple. So I hope you are clear with the basic terminologies over here, and in the next session we'll be taking more problems, more concepts on sets. Do revise this session and the previous one. Bye bye.